A super common conversion whenever we're looking at this and when we start looking at the unit circle and just angle measurements in general is to talk about angle measurements in terms of radians. 1 radian is the same as when my arc length here, so an arc length is that distance around the edge of the circle, right? So when this arc length is equivalent to the radius. So however big this circle is, when my radius and my arc length are equivalent, that is considered 1 radian. Or I should say where maybe. No, when the radius equals arc length. That is 1 radian, which is approximately 57.3 degrees. But here's the kicker to this, and this is how we're actually going to use radians. Radians for us are going to be in terms of pi. Because I know I'm going all the way around the circle, so the circumference of a circle is 2 pi r, right? So if I'm looking at this, if the whole circumference all the way around is 2 pi, that radius, then r shows that the radius, so that whole 2 pi that I'm looking at is equivalent. So all the way around my circle, this full amount is going to be 2 pi. So 360 degrees of my full circle is going to be a full 2 pi, especially if we're looking at our unit circle, which just makes it easier to work in terms of, right? So that full 2 pi goes all the way around. So if I'm looking at this, that'd be my 2 pi radians. So my 360 degrees is equal to those 2 pi radians. Well, we're not going to deal in those great big huge numbers, right? So if I'm looking at this and I divide both sides by 2, then what I actually have here is pi is equal to 180 degrees. Radians doesn't have a, sometimes people write RAD, but it doesn't have a symbol that goes with radians. If you're talking about something in terms of radians, you don't put a measurement on it. You just know that that's radians. If you have an angle measurement in terms of pi, it is understood that you're talking about this in terms of radians. All right? So if I have this value here and I want to figure out per degree, degree 2 radians, 1 degree is equal to pi over 180 radians. Do you see that? And all we've done here is said, okay, divide this by 180, divide this by 180. So pi over this 180 is going to leave me with that 1. That's just figuring that out. If I want to go from radians to degrees, then 1 radian is we're going to do the exact same thing. To get radians by themselves, we're going to divide by pi. And so now I have is equal to 180 over pi degrees. Okay, so 180 degree divided by pi. It is important whenever we're looking back and forth on how to get these between degrees and radians, radians and degrees. We are going to be using these very similar to each other, and there's going to be some very common ones I'm going to show you here very shortly that we're going to look and see how these are equivalent. All right, but let's look back through this right now in order to pull this off. If we want to convert these degrees to radians. Example 5, convert degrees to radians. So we are just going to take 45 degrees as our first one. So if I'm going to convert degrees to radians, when you go through, because you're making that conversion, if I want to end up in radians, radians are in terms of pi. So I'm going to multiply by pi over 180. All right. when I convert the other way, if I want to end in degrees, then I put the 180 on top because we know that these are equivalent. Okay, so if I have this, well, I don't know, what is that? 45 goes into 180 how many times? 4? Is it 4? Yeah. So now I end up with 45 degrees is equal to pi over 4 radians. All right. What if I have negative 270 degrees? Well, it's the same thing, right? You're just going to take your negative 270 and you're going to multiply that by pi over, I'm going to do that instead of the dot, pi over 180. Then let's simplify that. What happens here? 90 goes into that, leaving me with a 2. 90 goes into that, leaving me with that 3. That negative 3 there. So then I end up with negative 3 pi over 2. Negative 270 degrees is equal to negative 3 pi over 2 radians. Now I'm writing out the word radians here just because we're doing this, but normally you would just write negative 3 pi over 2. So those are nice little easy ones. Well, what happens if you don't have a nice little easy one? It doesn't matter. If I want to take 249.8 degrees, all right, then you're going to take 249.8 times pi over 180. We can't do this one in your head so much, so you're just going to have to plug that in. When you plug that into your calculator, then use the actual pi symbol. We're going to round this one to the nearest thousandth. So we're just going to end up getting 4.360. Just plug that into your calculator. All right. So the moral of this story is sometimes whenever you're looking at this, most of the time when we talk about radians, we're leaving this in terms of pi. If you get some freaky decimal, boy, then you're going to get some freaky radian, right? That's just how that's going to work. Okay. You can convert from degree to radian. Oops. I ran out of room. So now, oops, I did run out of room, didn't I? Yeah, I was at the bottom. So, hang on. Let me take this. I was actually prepared on this one. And then let's do some conversions here. We are going to convert from example 6, radian to degree. If we're going to convert from radian to degree, and I take 9 pi over 4, and you don't put anything behind it because it's just understood. If my goal here is to get this in terms of degree, then I want to multiply by the degrees on top over pi. Because now my pi's cancel. Do you see that? And then I'll just be left with that angle measure here. So whenever you multiply this and you can simplify this and divide it out. Let's see, what do we got here? 4 goes into 180. How many times? 45. So 9 times 45 is going to give me a what? 405? Is that what I'm getting? 36. Yeah. And you got a calculator. I've got mine sitting here. I ought to just use it, but I didn't. Either way. The same thing is going to happen if you plug this in to a negative. Negative 5 pi over 6. Well, just do work. Negative 5 pi over 6 times 180 over pi. The goal here is when we're looking at this, you want to lose those pi's here. 6 goes into 180, what, 30 times? So 30 times 5 would be negative 150 degrees. Not too bad, right? Good. And you're doing the exact same thing when if you have some different radian, 4.25 radian. If there's no pi there, then you have to write the word radians behind it so that you know exactly what it is you're doing. So 4.25 times 180 over pi. That one you just have to chug out. Throw that into your calculator and you get 243.5 degrees. All right? Okay. So just putting in your calculator. The majority of everything we do are going to be like this up here in terms of pi and working it out. All right, case in point, la. This, ladies and gentlemen, is where we are going to be living the majority of our time. Here are the common angle measurements, and we're going to spend a lot more time on this, so I'm just briefly going to talk about it right now because our whole next section deals completely with the unit circle. So we'll spend a lot more time on it. But for now, I'm just going to barely introduce this. Super common ones that we have. So we already did the 45 degrees to see that this is pi over 4, right? Your 30 degrees, your 60 degrees, all your quadrantals. So basically this is just saying, here I have my 30 degree here, and I have 30 degrees up here, right? And then here I have this 60 degree and 60 degrees, of course the 45s, and that goes all the way around. This is going to be common. The blue is obviously your degree, the red is your radian. So this is our unit circle, and we're going to get real good with the unit circle. All right, so sit tight with that for a little bit because we're going to spend a whole section on it, all right, with our unit circle. But converting back and forth